Hello, I'm Eder Alejandro Valencia Cornejo, and I'm going to talk about internal combustion engines, specifically about its cycles. Well, the goal of this presentation is to know the basic engine cycles and new alternatives that seem to be helpful in reduction of pollution. First of all, what is an internal combustion engine? It is a well-known fact that an ICE is any engine that operates by burning its fuel inside the engine. ICE is used for mobile propulsion and to provide high power to weight ratios together with excellent fuel energy density. Here we have some applications. In this picture we can see various engine parts, but the main parts are the piston, the crankshaft, the cylinders, the piston rods, intake and exhaust valves and ports, and in some cases the combustion chamber. In this picture we can see the movement of the engine, so keep in mind the movement and the main parts. Most ICE, both spark ignition and compression ignition, operate on either a 4-stroke cycle or 2-stroke cycle. The 4-stroke engine cycle begins with intake stroke, where the intake valve is open and the air-fuel mixture is pushed into the cylinder as the piston travels to the bottom dead center. Second, compression stroke. All the valves are closed and the piston travels to the top dead center. This compresses the air-fuel mixture, raising pressure and temperature in the cylinder. And when the piston is near to TDC, a spark plug emits a spark that combusts the air-fuel mixture. Then, expansion stroke. The piston is forced down by the pressure wave of the combustion. This is the stroke which produces the work output of the engine cycle. Finally, the exhaust stroke. The exhaust valve is opened and the piston travels to the TDC to push exhaust gases out of the cylinder. Near the end of the exhaust stroke, the intake valve starts to open, so when it's full open, the new cycle begins. Two-stroke engine cycle. The main differences between two-stroke engine and four-stroke engine is that the ports, intake and exhaust, are controlled by the movement of the piston. First, the combustion occurs very quickly, and then in the power stroke, the ignited fuel charge forces the piston down until the exhaust valve is opened and the blowdown occurs. When blowdown is nearly complete, the intake slot is uncovered and the intake fuel enters under pressure, pushing the remaining exhaust gases out of the cylinder. This process is called scabbering. Finally, the piston passes BDC and very quickly covers the ports and the compression stroke begins, where the piston starts to compress the air-fuel mixture in order to combustion occurs, and the next cycle begins. In this diagram we can see the main differences between 2 and 4 stroke. In these two engine cycles, the one of the most important variation is the fuel injection. The fuel injection is a system that supplies vehicles fuel directly into the cylinders of the intake manifold of the engine, eliminating the need for a carburetor. Now, for new alternative that seems to be helpful in reduction of pollution, the homogeneous charge compression ignition is the ultimate combustion method for achieving both CO2 reduction and clean exhaust using a ignition of gasoline and most alternative fuels, especially dimethyl ether, as in a diesel engine. Well, this engine is a mix of 4 and 2-stroke engines. So how does it work? The HCCI. So in an HCCI engine, which is based on the 4-stroke or Otto cycle, it has just one variation from the 4-stroke engine. So it begins with the combustion in order to get power. Secondly, at the exhaust stroke it occurs the variation, because in the cylinder isn't fuel empty, there is a residue of exhaust gases due to increase the temperature of the air-fuel mix introduced in the intake stroke. Finally, at the compression stroke, the temperature and the pressure starts to increase until the combustion of the air-fuel mix and the cycle repeats again. It is important to control the whole process due to fuel delivery. The HCCI it has autoignition, but it varies depending of the many factors, also using alternative fuels. Unfortunately, it has been very difficult to apply HCC technology to real production engines due to, first, the ignition timing and combustion phasing in the HCC engine cannot be directly controlled. Second, it has low power density because of its lean combustion nature. Finally, the HCCI engine has limited operating range between knock and misfire boundaries. Here is a table that compares the three methods, just remembering all the key points of each one. In summary, the internal combustion engine single-handedly propelled life into the modern 20th century of today by setting the stage for modern transportation and creating the platform for more modern innovations of the future. And in my personal opinion, as far to accuracy and sustainability, there is still work to be done. Here are my references, and thanks for your attention.